صح, yeah, the uni fair. Inshallah, I'll go. Kid, everyone has their own time slots, so I don't know if we'll be able to meet. Anyways, question 2. In which block of the periodic table is manganese located? So easy.
Manganese is in the D.
D block. Easy.
Yeah.
Alright, predict the position of X if this has the config. What's this stupid question? You can do it, right?
Yeah.
How do you
First
do
we
it?
see
And I by the way, quickly, I don't look at any of this. This is
chlorine.
group what?
Ah,
7.
group. Yeah.
Yeah,
Chlorine.
period 3.
3.
So you go,
Chlorine.
yeah, chlorine. Group 7, period 3 is chlorine.
Oh, I have my periodic table open as well.
Ah, okay, perfect. Yeah, that's perfect. Alright, next we have, what are the factors that affect atomic radius? Yalla. Yalla, let's write them down.
Uh,
3 things. Atomic radius is what? Shielding
the
effect.
shielding effect, number of protons.
In other words, shielding effect, that means number of what?
No, core electron.
Perfect.
We have number of protons.
Number of protons, which means what?
The group.
Yeah, I know. So what does the number of protons determine? The charge of what?
Atomic number. Atomic
Okay,
number.
or
Atomic.
no, nuclear charge is the word I'm looking for.
The nuclear charge.
Okay, so I'm gonna put the first one, nuclear charge, and then in brackets, number of protons. Nuclear charge, brackets, number of protons. Don't do the quiz, huh? It's pointless. And
Okay.
the last one is, مش صح, we said down a group.
Atomic radius
Sorry. Yeah, down a group, atomic radius decreases. Oh, wait, no. No, it increases, sorry. Yeah, mixed me up. Do you know why it decreases down a group? Sorry. Yeah, blah, blah, blah. Do you know why it increases down a group?
Because when you go down the group, the nuclear charge becomes greater, so the shielding effect.
Keef. Down a group, we're still all in +1. So how is the nuclear charge?
Okay.
Down a group, what's gonna happen? The number of core electrons increases. Oh, got me?
Yeah.
طيب, what else? مش down a group, energy levels increases?
Yeah.
Yeah, exactly, صح? Since energy levels increases, that's the last one. They call it quantum energy levels. تمام?
Okay.
So atomic radius down a group, let's put it on the side. Atomic radius increases down a group, decreases across period. Across a period, why does it decrease? Do you know why?
Across period, why the atomic radius decrease?
Yes.
Okay, so if you're going across the period, the number in the nuclear charge.
Wait. Stop talking. That's literally question 5 and 6. We're gonna do it now, okay? Why is the atomic radius of fluorine smaller than nitrogen? So if you take a look, fluorine is in group 7, nitrogen is group 5, صح? Are they in the same period?
Yeah.
Okay, so that means down a period, they're saying that the atomic radius is what? What's happening to it?
It's
decreasing. Alright, so why would the atomic radius decrease down a group? Justify for me.
Because
well, I feel like one of these will come in the written. I'm not gonna lie to you.
Same.
Yeah.
It's less energy to like remove it's called the quantum energy level.
Okay, what are the 3 factors that affect atomic radius?
The shielding effect, nuclear charge, quantum
Okay,
energy level.
so since we're decreasing, that means one of these are getting bigger, right?
Yeah.
Alright, so is it the quantum energy levels? Is n increasing as you go down a period?
Yes.
How is it increase? No, right? It's the same period. If this is period 1, then it's all n equals 1, right? Actually, it can't be n equals 1, because n equals 1 is just 2 elements, hydrogen and helium. You know this, right?
Yeah.
N equal 2, مثلا, it's all of these elements. صح? There's this one period. So could it possibly be quantum energy levels? Is that the one changing now?
No.
Type nuclear charge. Is that one?
Nuclear charge, number of protons, yes.
Yes, صح? Shielding effect, number of core electrons. As you go across a group, is the number of core electrons changing?
Yeah.
No, it's not.
Wait, what?
As you go down a period, across a
Yeah.
period, number of core electrons does not change. You want to test it? Yeah, let's test it. Just so you can prove it. NaMg, same period, right? Na11, Mg12.
Yeah.
صح؟ يلا give me the config.
1s2, 2s2, 2p6, 3s1.
Mg.
Same thing, but 3s2.
Perfect. How do you calculate core electrons in the first one? It's 11 minus what?
Core electrons, 11 minus 8.
What? You don't know?
Wait,
Okay, this is perfect. Good thing I'm telling you this. Core electrons are electrons that are not valence. How many valence electrons I have here?
also it's like the ionization, right?
Tell me how many valence do I have here in Na?
3.
Give three. Do you know what
Is
a
it
valence
one?
electron is?
Isn't the valence like the outermost shell?
Exactly. Which is the outermost shell? In three, right? Three is the outermost shell. How many electrons do I have in it?
1.
One. You understand?
You asked how much are not valence?
Yeah, yeah. How many valence here in Na?
1.
One. So, how do you know how many core electrons is? How many total electrons do I have? 11, right?
Yeah.
Minus. How many valence?
1.
What do you get?
10.
So 10 core electrons, right?
Yeah.
How many total electrons do I have here? This is Mg, right? Mg12. صح?
Yeah.
How many total do I have?
12. The core electrons
Yeah,
are
so how many?
12.
This is 3s2. How many valence do I have?
2.
How much do I get?
10.
So didn't I just prove to you that as you go across a period, مش Na is here, Mg is here, right?
So they have.
As you go across a period, they have the same core electrons. So here, is the core electrons changing?
No.
No. So what's changing?
Shielding effect. No, it might be
Nuclear charge. Okay. طيب. Let me use the area eraser because ما بنخلص اليوم. Okay. Let's see now. How about? So what did we say? If it's not the shielding effect, what's it gonna be? The nuclear charge that's changing, right? Always, I told you. As you go across a period, what's happening? What was the name of my uncle?
And
Jenk.
Junk, yeah.
Right, Jenk. صح?
Yeah.
What does it stand for?
I forgot.
Greater effect of nuclear charge.
Nuclear charge. Okay.
فهمت علي?
Yeah.
So always, if you're going across a period, whether they're talking about atomic radius or whether they're talking about ionization energy, what do you refer to?
Junk.
عمو Jenk. Okay? Greater effect of nuclear charge. يلا. So, let's explain. As you go across a period.
Do I need to specify what stays the same?
Let's think. As you go across a period, let's put in brackets N and F are both period 3. Since we're comparing two elements, I need you to be very careful, okay? And I'm speaking from experience from IG Chem. And you can say, شو خاص IG AP, bro? What is IG? This is AP. No, wallah, there's so much in common, okay? Every exam board looks for specific things, okay? And the thing that they have in common is that when you're we're comparing, right? Fluorine and nitrogen, right? You need to use words like smaller, less effective, more effective, bigger, comparative words. Do you get what I mean? You can't just say as you go across a period, it's smaller. No, you have to compare directly nitrogen and fluorine. So let's take a look. As you go across a period, fluorine and nitrogen have the same number of what?
Same number of core electrons.
Okay. Therefore, what does that mean? They have the same what?
Energy level.
No. If they have same core electrons, the same what effect?
Shielding effect. Do we need to say the energy level or no need?
And you can add it. What do you lose? And they have the same number of quantum energy levels.
the quantum energy level is like 1s2 to 1 and 2. Yeah,
Yeah,
what's
one,
called
two, three,
s2.
four, right?
Yeah, the 1, 2, 3.
Okay. So what's the change?
The nuclear charge.
Therefore, the factor affecting the atomic radius, I'm gonna put AR. So in the exam, please put atomic radius.
Yeah, I know. I don't do circuits.
Yeah, of
So,
course, no, don't take the risk. Is uh, a greater effect of nuclear charge. Since fluorine has a nucleus that what you could say that has a greater charge.
can we say there's more like nuclear attraction?
Yeah, I'm gonna get to there. That a greater charge than that of nitrogen. Hence, it attracts the valence electrons. What electrons are they attracting? The valence ones, the outermost electrons, صح? They're bringing the outermost electrons closer towards the nucleus, صح?
Yeah.
Yeah. Hence, it attracts the valence electrons more better. You could say better or more strongly, or closer. Let's say closer
To the nucleus.
than nitrogen. Get it?
Yeah.
Yeah.
So that's how you solve it.
Mm-hmm. Don't leave a single word out. Chemistry, they want you to add as many words as you can. Anything, يا أخي, you're not gonna lose shit. Just say yap, يا أخي, yap. Okay? Yeah, the next one. What's the next one? Read 6 for me.
Explain why the atomic radius of magnesium is smaller than that calcium.
Let's take a look. Magnesium, calcium.
Group 2 and group 3.
No, keep group 2, group 3. They're both group 2.
Yeah.
Yeah. So
Three,
now
two,
we're
and
going down a what?
group.
Let's take a look. As you go down a group, you have to say this. From Mg to Ca, comma. What changes?
So, quantum energy level
Okay.
and the shielding effect.
Okay. Perfect. They didn't talk about shielding effect in the solution for some reason. Both belong to group 2. Calcium's valence shell is shell number 4. Okay, whatever. Since the valence energy of nucleus experience greater shielding,
Wait, wouldn't have the same shielding effect because, like, no.
no, shielding effect should be greater, right?
Yeah, shielding. Yeah.
Okay,
I think why they didn't add shielding effect because, like, doesn't support the claim.
how does it support the claim? If there's a greater shielding effect, doesn't that mean the atomic radius is smaller?
No, it doesn't mean if you have greater shielding effect, you have more number of core electrons. That mean it will be harder to attract to the nucleus.
Let me think. As you go down, number of core electrons increases. Therefore, yeah. You keep on mixing me up, man.
What did I do wrong?
Yeah, good. You fixed it. As you go down the group from Mg to Ca, what's it called? What increases?
The quantum energy level.
The quantum number. The quantum number. No, quantum energy level. You could say that. Yeah. You're right. Sorry. Energy level. I'm just gonna put this. Therefore, let me think. Quantum energy levels. Shit. The quantum energy levels increase. Therefore,
The atomic radius is smaller.
1, 2, 3, 4. This is calcium. 4.
Yeah.
1, 2, 3 mg 3.
Why is magnesium smaller, right?
Let's take a look. Look here, huh? Over here, when you have, they said Ca should be, yeah, Ca is larger, huh?
Yeah.
Okay. Ca is larger. That means the valence
So it's,
electrons are further away from the nucleus, right?
yes. So
Ca
is it
has more. Listen,
electron,
listen.
electron?
Ca has more
Oh,
core electrons.
I got
Mg
it.
has less core electrons. صح? Which one
Yeah.
has greater shielding effect?
Greater shielding effect,
Mm-hmm.
calcium.
Calcium. You answered it. That's your answer.
Can we say about the electron repulsion?
Electron repulsion. No, ما خص. Electron repulsion is when you have the other thing, the one with the. You remember the exceptions for ionization energy. Do
Yeah,
you
I
remember them?
remember the.
Yeah, yeah.
This is one of the exceptions. Okay.
Yeah, yeah. As you go down the group from Mg to Ca, the quantum energy level increases. Therefore, the number of you can say this is how you go. The number of core electrons increase, and Ca experiences a greater or smaller shielding effect.
Greater.
Perfect. Greater shielding effect,
And the smaller, what's it called? Smaller nuclear attraction.
and perfect, and therefore, what experiences? You can't just say Ca has less nuclear attraction. What are the specific things that get attracted to the nucleus?
The valence
The
section.
valence electrons experience less nuclear attractions than Mg. Therefore, this arrow means therefore Mg has, or no, you could say Ca has a larger atomic radius. Capiche?
Capiche?
What do you think?
That's larger. Yeah.
Not bad, huh?
Yeah.
Yeah, the question's out. It's a grid. Atomic and ionic radii exhibit periodic trends. Which of the following graphs represent the correct periodic trend of atomic radius down a group? Before looking at the graph, what
Banner group
happens to atomic radius down the group?
increase.
Perfect. So which one is gonna be?
What's it called? The top right.
Perfect. This is something else. Why is it going up then down and up then down? What is this
The,
trend? This is what?
the exception trend.
Which is about what? Is it about atomic radius?
No,
What's it
the
about?
ionization.
Perfect. Right.
Ionization.
Okay. How do the atomic radii change across a period and down? We said down a group. What happens?
It increases.
Okay. Well, across a period from left to right,
Decreases.
decreases. Why does it decrease orally? Because we just wrote it down. Why does
Yeah.
it decrease across a period? Because of what is the name of the guy?
Uncle Junk.
Uncle Junks. Yalla. Uncle Junks, huh? So
Yeah.
we say it decreases from left to right because the greater nuclear effect of nuclear charge attracts the valence electrons more. Right?
Yep.
Okay. Um, how about down a group? Why does it increase?
Increase, you have more number of core electrons.
Before that, you say.
Greater shielding effect.
No, before that, what increases? The N, right?
Then,
Quantum energy level. As you go
yeah,
down a group, the quantum energy level increases. Therefore, there will be more core electrons. Therefore, there will be more. What does core electrons give you?
less nuclear charge.
Shielding effect. Therefore, more shielding effect. Therefore, now you say less nuclear attractions. Therefore, valence electrons are further away. Got it?
Yep.
Yeah. Not hard. I find this chapter easier than the rest. It's all easy. So far, there's nothing too hard, but there's just a lot to process in your head.
Yeah, I just need to practice it for the written. That's why.
Exactly. That's why written you need to be good at talking. And alhamdulillah, I don't shut up. I'm very good at talking.
We have experience.
Yeah. How does the ionic radius of an ion compare to the atomic radius of its atom? Type. Before this,
Ah,
let's look at x minus, x plus. Which one has a greater atomic radius?
X-Man,
Which one has the smallest?
X plus.
Okay, so let's give a small explanation. So let's take a look at the cation, right? How do you get a cation? What happens?
Lose the electron.
All right. So the cation is formed when it loses the valence electron, right?
Yeah.
So that means the electrons now are they closer to the nucleus or further?
Closer.
Okay. Let me. Yeah. Okay. So here's a good way to remember it. Okay, you're playing football, yeah.
Yeah.
ماشي. It's kind of like one team is the nucleus, one team is the valence electrons. They're kind of like fighting from each other, okay?
Okay.
Okay, let's say the valence electron team, one of them gets a red card. تمام?
So it gets kicked
Right?
out.
Yeah, so he gets kicked out. He leaves he leaves the field, right?
The core electrons have an
Yeah,
advantage. They can push
exactly.
the
Therefore, no, the nucleus has an advantage now, so he's gonna push him closer. فهمت شو قصدي؟
Yeah.
خلاص تمام. So that's why, so you say, to form a cation, the atom must lose an electron. Therefore, it will be closer to the nucleus and experience greater nuclear attractions, and therefore, it has a smaller radius than the atom, a smaller atomic radius. However, how do you get now an anion?
An ion, you gain electron.
Okay, continue.
So when you gain electron, okay, you have more number of core electrons.
No. You never gain core electrons. Core electrons is the number that never changes. Okay?
Okay, so gain electrons.
Yeah, you gain another electrons. فتفضل انه مثلا give me an anion, any anion in the world. Cl, right? Cl, let's say easy.
10 minus.
Okay, Cl. If you look at Cl minus, Cl بلد minus. Look at the final shell. It's 1s2, 2s2, 2p6, 3s2, 3p5, right?
Yeah.
If you look at the p shell, let's take a look here. Right? طيب. Cl minus, what's gonna happen? Whatever. But this becomes 3p6,
Yeah.
right? Where does the electron go? Here,
Yeah.
right? Type, what does it give you? More what when you have two electrons beside each other?
More valence electron.
You told me, you asked me 5 minutes ago, Walid, when will I use something? Huh?
Electron.
Exactly. So when you gain an electron, there's going to be more electron repulsion, right? But let's draw it like this. Cl hone, whatever, you have your shells. Let me draw it better. That's disgusting. Cl. Disgusting. Cl. It's 3 shells, right? You got an electron here. Well, then the electron came here, right? The new guy. صح?
Yeah.
Okay, for this guy, he's pissed from this guy. He's saying move away. He's telling him move away. But since there's repulsion, the radius is... What's the radius? It's the distance from the nucleus to the outermost electron, right?
Yeah.
If he's repelling it, okay, the outermost electron is going to go a bit further. So what's going to happen to the radius? He's going to increase. تمام?
Yeah.
You got that point?
Mm-hmm.
You know, chemistry is nice when you understand it. Like, people say you just memorize chem, or I don't know what. They're right, I'm not gonna disagree. But really, there's an understanding, side towards it. طيب, the figure below shows the trend in ionic radius across a period. Why does the radius decrease from Na plus to Si4 plus? So the first thing I always tell you, Abdelrahman, is when comparing ionic radius, you check whether these ions are what?
They have the same number of electrons.
And what's the name of that?
To be honest, I forgot that.
Iso?
Isoelectron.
Perfect. So let's check if they're isoelectronic. Na plus has what? 10. Mg2 plus has 10. Al3 plus 10. Si4 plus, if I'm not wrong, it's 14, so it will get 10. P3 minus is not 10, right?
P3 minus.
Or is it?
P3 minus, wait. No, it's 18.
18, صح?
Yeah.
Okay, S2 minus 18, Cl minus 18. صح?
Yeah.
Am I correct? Is Si4 plus 10 also?
Si4 plus, if it's plus, doesn't that mean
I know, because I don't have the periodic table in front of me. What's the one for Si? Well, how many?
14.
Okay, perfect. So you have 10, 10, 10, 10, 10, 18, 18, 18. Why does the radius decrease from Na plus to Si4 plus? Let's go from here to here. تمام? Alright, let's take a look. When you have two ions that are isoelectronic, how do you compare them? How do you compare the radius when they're isoelectronic? What do you look at?
The quantum energy level, shielding effect.
La. Okay, no, that's perfect. Correct. What you're talking about is when I'm talking about atoms. But I'm telling you, I'm talking about isoelectronic species. Did I tutor you for chem last week? I did, صح?
Yeah,
I did for the last CA. This week we didn't have. It was the week before it we had, right?
yeah.
What was the thing I told you? Abdurrahman, when you see the question asking you, arrange the ions in increasing atomic radius order, I told you, how do you check it for ions? 99% of the time, the ions will be what?
I
Isoelectronic.
check.
But you have to
Yeah,
check it to make sure. But 99%
yeah.
of the time, it's going to be isoelectronic. Type cool, they're isoelectronic. I told you, top, what do you check? The one with the greatest atomic number will have the smallest radius or biggest radius?
Uh, Biggest radius.
Smallest radius. Okay, greater atomic number means what? Greater what? In greater charge of the what?
Uh, Repeat.
Greater atomic number. Okay, Si. Let's look at Na. You have Si, right?
Yeah.
What's the charge of this nucleus?
After the electron loses?
No, no. Still, even if the electron leaves, what's leaving from the nucleus?
No.
No. اسمع عبد الرحمن.
حبيبي.
Na11 and
Yeah.
Na plus.
Ah.
You know they both have the same nuclear charge, right?
Yeah.
Why is it? Why doesn't it change? Because the electron that's leaving here is what? It's an electron in the outermost shell. شو خاص
What's that?
nucleus? Nucleus is down here. Nucleus lives his own life. He's undisturbed. He's like the king of the atom. He doesn't give a fuck about anyone else. You get me?
Okay. Yeah.
100%?
Yeah.
I had to make sure you know that because it would have been a problem. ما قصدي شيء والله بس I need to make sure.
No, no, yeah.
Okay?
Yeah.
So the nucleus here is what?
No, didn't you say it has to be with the, it's called-
Plus 11, right?
yeah,
Silicon's how much?
plus 14.
Which one has a greater nuclear charge?
That's right.
Si, right?
Yeah.
Okay. Tell me, greater nuclear charge, that means what? Greater?
Greater than nuclear charge, that means it's called number of protons increase.
Okay, but in terms, نحن we're talking about what? The radius.
The
What does
radius.
that have to do with the radius if there's a greater nuclear charge?
There's a greater nuclear charge, doesn't the radius increase?
Really?
Because if you have more protons, doesn't it?
Greater nuclear charge
Oh,
means stronger nucleus. That means the nuclear forces of attraction will be smaller or weaker.
okay.
You get
I
me?
was, yeah, I was thinking about the electrons.
Yeah, I get what you mean. So again, try and explain to me from Na plus to Si4 plus. Why is the radius decreasing? أول شيء there. الحمد لله.
Alhamdulillah.
يهدينا ويهديكم الله. أول شيء they're isoelectronic. Then,
Yeah.
what causes the Si to be smaller than the Na?
And nuclear charge.
Nuclear charge. Because Si has a greater what?
Nuclear charge.
So how do you write this down? You say both Na plus and Si4 plus are.
Isoelectronic.
Yeah, let's write this down. You know what? I'm gonna write it down. Here. Both Na plus and Si4 plus are.
Oh, so it can have more nuclear attraction.
Exactly, you got it?
Yeah, I got it.
Therefore, we say but Si4 plus has a greater
Nuclear charge.
nuclear charge than.
And A plus.
Therefore, what's gonna happen?
The radius.
Okay, explain. Why will it decrease? I know we know it's gonna fucking decrease, but how would that decrease if there's a greater nuclear charge?
If there's a greater nuclear charge, there will be more nuclear attraction.
Perfect. There will be more nuclear attraction between what and what?
And the nucleus and the valence electron.
In what?
In Si4.
Please always, whenever you can, remind the person correcting exam about which atom you're talking. Okay?
Okay.
Always try to remind. In Si4 plus, therefore, the atomic radius will decrease. Got it?
Yep.
Yeah. Part B. Trace on the same graph a sketch of the atomic radius trend of the atoms corresponding to the given ions. Type. atoms corresponding to given ions. يعني instead of Na plus they want what?
Na,
Instead of Mg plus what?
Mg.
Okay, so let's look at the cations first, then we'll look at the anions. صح؟
Yep.
طيب the cations أكيد they're gonna be their radius if as a cation is gonna be smaller or bigger than the original atom.
The cation will be smaller.
Smaller. So if I were to place a dot, will I place it above or below?
Above.
Perfect. So we can like kind of do this.
Face it.
All right, but don't just copy a take. Why?
No, because if you do that, it's decreased. So you have to put like opposite to it. Right?
So let's take a look. Let's take a look at Na, Mg, Al. This is a very nice written question, huh?
Yeah, I know it
Well,
is.
I'm telling you, the course is actually nice. By the way, these are FRQ questions, huh? If you
Yeah.
don't know, these are literally coming out of FRQ questions. Okay.
No, I'm doing the AP exam for good to know.
Yeah, good to know. What was I saying? Hey, let's compare these. NaMgAlSi, aren't they across the same period?
Yeah.
Okay. Across a period, what happens?
Cross period, atomic radius decrease.
Perfect. So that's why it's decreasing. Let's go. Heck, heck. But don't make it a straight line, heck. Look at how it's decreasing here. You get me?
Yeah.
And no,
Yeah.
copy the trend. Like the trend is like strong decrease, then minimal decrease, then very minimal decrease.
Then up.
Yeah. Then we reach the cool boy anions, right?
Yeah.
طيب cool boy anions شو قصتهم? Are they bigger or smaller than the original atom?
Bigger.
Okay, so that means am I gonna place the dot below or above?
Below it.
Below, right?
Yeah.
So we're gonna continue. Instead of up there, we can go like here, right? Heck. Still, it has to be smaller. Why smaller? Because we're still going across the period, right?
Yeah.
صح?
Okay.
And then S again, since it's across the period, it's a bit smaller. Excuse my drawing skills, huh? Let me fix it for you.
Yeah.
Okay.
So why didn't you do like from the cation to the anion a bit lower, like great decrease? My here there is a great increase.
1 second. What do you mean?
Like why did you make it a bit small decrease? Why didn't you make a big decrease? As they did.
You mean why is it such a big decrease here?
No, when you go from the cation to the anion.
You mean like over here. Don't forget, we're talking about this is what Na, this is what
Yeah.
Mg,
Mg.
this is what Al,
Al.
this is what Si.
That's
Now
all.
whatever I put here now is gonna be P. So on this new graph, I'm only considering what the ions or the actual atom.
The actual.
The actual atom. In the atom, did I talk about anything? We know there's one trend to follow with the atoms. What is it? Across a period, what happens?
The atomic radius decrease.
So that's all you need to consider, because now we're not talking about ions anymore. Here, why is there a jump? Because we went from cation all the way to anion. فهمت قصدي? Here we're still talking about original atoms. But that's a really good question. Good question.
Okay.
Yalla. So here, again, we're gonna keep on decreasing, right?
Yeah.
So again, we could say مثلا here. Okay. This will go again below. And then here again, go below. Cool. That's the answer. Their answer is a bit different. It goes here and then decreases a bit more. There's no specific trend. Like that's more advanced chem. You could label P, S, C, L. But you get what I mean, no?
We have to name them, صح?
Label it صحة السلامة. Have you heard that before?
What?
صحة السلامة.
No.
We say it in Lebanon a lot. It means stay on the safe side. You get me?
Okay.
طيب. Question 9. Answer the following questions related to selenium and its ion Se. طيب. Se2 minus, I mean. Write the electron config. You know how to write configs. Skip it, huh? Let's do it fast.
Okay.
Se.
Se, it's group 34 if I'm not mistaken. So.
Group 34?
Se. No, like, I'm not talking about group, I mean, like, oh my god.
Atomic number, you mean?
Yeah, talk about my life. Let
Yalla.
I'll tell you why I'm off today, okay?
What's up?
I want to go eat at Nando's today, okay?
Nando's. I love Nando's, you know?
Yeah, I love it so much. I
Yeah.
go to WTC beside me, okay?
What's
I
that?
go
What's
up
that?
WTC mall.
WTC?
It's a mall, it's a mall, okay?
Alright.
Usually there's Nando's there. I go up, I find that they removed the whole entire place and they're doing
What?
renovation. They're doing renovation for a cinema.
What?
I get so pissed. I go down to the food court and just eat anything.
I'm sorry, wallah. You were going alone?
Yeah,
What do you usually get from Nando's?
the it's potato with two sides.
Yeah, yeah, I love it.
It's so annoying. That's why I'm very off today.
Alright, my fault, my fault, my fault.
Like, can you give me one sec, please?
Yeah, yeah, sure, sure.
Okay, I'm back. Sorry for that.
Don't worry, Habibi, don't worry.
Okay.
Yalla, let's continue. You know, cheeky break, you know. Cam needs breaks, bro. Wallah.
Well, that's on that.
Bitch ass subject. I'm not. I think I made it obvious to you that I really don't like the subject. But
No,
it's
you made it obvious in the videos.
yeah, since last year, huh?
Yeah.
Okay,
I
المهم.
used to love chem so
You
much.
used to love Cam?
From grade 10, because I like calculations.
Yeah, okay, exactly. Back then it was actually شو اسمه calculations. But
But
now
then the memorization thing destroyed my life.
exactly, bro.
Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4.
The ion.
So same thing, but 4p6.
Perfect.
Just give me one second, sorry.
Don't worry. Don't worry.
Yeah, I'm back, sorry.
يلا
You're not the only tutor I have.
يلا. What? And you're doing two classes at once?
That tomorrow, I might like do extra revision because
Cam?
yeah.
Shit, bro. You completing the Infinity Stones, bro.
The problem is even if I complete the Infinity Stones, I still can't wipe the whole entire map.
Why? What do you mean?
Usually, last year I had this last year and this year I have a tutor for every single subject there is, even Arabic and Islamic. تخيل?
Actually,
Yeah.
it's fine. You know, there's no shame in that, by the way. Well, that's great,
Yeah,
really. It's as long as you're doing good, that's what matters.
yeah, 94 and above. That's it.
One sec, one sec. Okay, okay. I'm sorry, sorry. I'm back. Abdelrahman, let's continue.
Yeah.
Explain why the radius is larger than that of the SE atom.
Okay, so you have more valence electrons, so less nuclear attraction.
One second,
So
one second, one second, one second. Abdelrahman, keep less nuclear attraction. Wait, 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 wait. Same atom, right?
yeah,
So for now, انسى لي ام nucleus because they have the same nucleus. You
okay,
get me?
yeah.
طيب. I told you between SE and SE2 minus what changed? What did it gain? It gained.
It gained 2 electrons,
How does the outer shell of SE look?
and the last one, so
It was
for
4p4,
S,
right? So it looked like
yeah,
this.
yeah,
Then the new one is 4p6, صح?
yeah.
What's different?
The last two shall
What happened?
gained an electron.
So these are 2, 2. This is 1, 1. When you have two electrons beside each other, what happens? What happens, Abdurrahman? What
No,
happens?
extra repulsion.
Exactly, that's all you need. I explained it earlier, I'm doing it now. If they ask you, why is it larger when you get an anion, what do you tell him?
Repulsion.
Repulsion. ماشي؟
Okay.
يلا. For what do I write?
So
SE2 minus
SE2 minus
gains 2 electrons. Sorry, SE, sorry. Let's see. SE gains 2 electrons to become
SE2 minus.
SE2 minus. This causes it, this causes the outer shell to outer P shell, let's say the outer P shell, yeah?
Yeah.
4P shell. Because you know in the exam, in the drag and drop, you'd have to say 4P, 3P, مدري شو. You remember
Yeah.
this? The outer 4P
Um,
shell to be fully occupied with double bonded. Let's actually say this. Let's. Do I say double bonded electrons? What do you think?
shouldn't we say there would be like a greater electron
Yeah,
repulsion
yeah.
of
Double
course?
bonded electrons, basically. Okay, occupied, causing greater electron. No, you know what I'll say? To be fully occupied with
Oh,
fully
that?
occupied
I know what it is.
orbitals, right? Because the orbitals are the ones that have 1, 1, صح?
Yeah.
Okay, with fully occupied orbitals, meaning the electrons will experience what?
Electrons will
Electrons
experience
in Se2 minus will experience what?
extra repulsion.
Greater. Come on, show extra repulsion. Phrase this better. Greater what?
Like electron
Electron.
electron repulsion.
Electron repulsion. Therefore, they will
SE.
be. Yeah, tell me, what do you want?
Yeah, they'll have like a larger radius.
Se2 minus will have further away electrons, and therefore the atomic radius will increase. Capiche?
Capiche.
Write equations to illustrate the first and second ionization energy of sodium. Fast, fast. This is so easy. First ionization, yalla. Na.
And a gas
Perfect.
to go at an A plus gas plus electron.
Second.
Same thing, but 2
Not
plus.
the same thing, tell me.
Like an A plus gas,
Perfect.
an A2 plus
Excellent.
gas plus electron.
So, and listen, if I say something يعني strict ما قصدي, you know, like I'm
I
trying to
know.
be, you know,
Trust me,
هيك.
I know from experience. That teaching this.
Yeah, no. And I'm very I don't want to say I'm a cool teacher. No, I don't think I'm 16, but you know, I'm trying my best to be as cool as possible. But at the same time, there are some ground rules. You know what I mean?
I know.
Yeah, I'm trying to get the point there.
Really, everyone asks me in class.
Mm,
Literally.
don't worry
I'm,
about
I'm,
it.
I'm used to be the smart kid in the
Eh,
school.
طيب يلا part B Abdelrahman. The second ionization energy of an atom is always larger than the first. Why? What do you think? I wanna like seriously.
Second ionization energy. So there will be, let's say, it will be like an extra jump.
No, no, don't say this. Okay, let's imagine what's going on. Okay, Mg 2 plus, right? It starts
Yeah.
as what? Mg, Mg
Then
plus,
and the Mg2 plus.
Mg 2 plus.
Does it relate to the core electrons?
Um, not really. It's related to
Uh,
nuclear charge. Let's
uh,
think about the same example I gave you with the football team. Do you remember the football team
yeah,
example?
yeah,
Okay, so here we're playing 11 versus 11. صح?
yeah.
So who's winning? No one's winning.
No one.
Here we're playing 11 versus 10, right?
Okay.
So who's winning?
The 11,
Who's the 11?
the Mg.
Like, who in the NG?
The nucleus.
The nucleus. So the nucleus here is winning, right?
Yeah,
So here, the nucleus and the valence electrons were sort of balanced, right? But when you go
yeah,
to Mg plus and you want to take another electron, the nucleus is sort of taking over, so you have to put in more energy. Does that make sense?
yeah.
Okay. How do you phrase this? Let's take a look.
I got it.
You'll say, I don't have space. I'll write it down here. 10b. The first electron is being removed.
Does it take like more energy?
Exactly. From a neutral atom. Whereas the second is being removed from a +1 charge atom. The same, in the +1, the same nuclear charge is attracting less valence electrons. Therefore, the attraction is more firm. You get me?
Yeah,
Capiche?
yeah.
Yeah, look great. This is FRQ, by the way, when they say FAS6.
Okay.
We'll do 10. How many parts is it? Only one?
So
Okay.
let me guess. All grids are FRQs.
I don't know والله.
I can guarantee you most of the grids are FRQs.
This is FAS. Maybe, yeah. But MCQ are FRQs, you know? MCQs مش FRQs. I think they're the FRQs are different. Like مثلا this one, we solved one that was like really nice. This one here.
Yeah.
Told you, I think this one will come. And this is
I
also
think
nice.
also 9, yeah.
Yeah. Yani these are, well, I'm telling you, these are nice questions. They're great practice. Where did we reach now? 10b, right? We did 10b.
Yeah.
Let's take a look. 10c, the second ionization energy of sodium is around 9 times larger than its first, while the third is only 1.5 larger. Then it's second. Suggest why this is.
Okay, second ionization is 9 times larger than first. Third
So
is
the
1
greatest
point.
jump is where?
Is it greatest jump is 2.
It's 2. Obviously انت you know sodium يعني. It's not
Okay,
rocket science. Is what group?
group 2.
Eh? Sodium.
Oh yeah, my bad. 20 plus group 1.
Group 1, right? Eh. Group 1, obviously, it makes sense that the ionization energy of the second one, IE2, right? This is IE2. What they told us the second ionization energy is
Yeah.
IE2. It makes sense that IE2 is 9 times larger than the first one. Because it's a group 1 element, right?
Yeah.
Obviously, it's only going to prefer to lose how many?
1.
1. صح؟
Yeah.
طيب.
Oh, well, this one's gonna lose 2, so it
Okay.
needs more energy.
So when you say IE2, the second ionization energy means how many are you losing? 2 electrons.
Yeah.
Sodium only prefers 1. But when you go and tell him 2 electrons, he's gonna be like, "Oh, you want to take another one from me? You're gonna have to go through who? The second shell. So that's why you need you need more energy, right?
Okay.
So what's the justification? This came in the exam. It was an answer. Let me write it down for you. What's the config of NA?
N1S2 to S2 to P6 and 3S1.
It loses 1 electron to become Na plus, where it's 1s2 to s2 to p6.
So it would be you need more
روق
energy
شوي
to.
Na2 plus 1s2 2s2 2p5 Na3 plus 1s2 2s2 2p4 صح؟
Yeah.
Here we lost it from which orbital?
Yeah, that's
S.
the
Here we
3S.
lost it from which orbital?
The P.
Here we lost it from which orbital?
The P.
Okay, انت برأيك. Okay.
Yeah.
Which orbital is closer to the nucleus, 2p or 3s?
2P.
So which one's harder to be removed, 2p or 3s?
2P.
2p. Did I just answer your question?
Yeah.
So if it's harder to be removed, do you think it requires more or less energy?
More.
You get me? Yeah. So how do you write this in chemistry exam terms, not tutoring terms? Let's take a look. (10C). The first electron is removed from 3s, while the second, because we're only in the question talking about IE2 and IE3, right?
Yeah.
Well, second and third are removed from what?
The P.
2p. You have to say 2p, huh? Don't say p.
Yeah, I know.
Okay. 2p is much closer to the nucleus than 3s. Therefore, it requires more energy to overcome the nuclear attractions and remove the electron. So they asked us 2 questions. They told us that the second one is 9 times larger than the first. Then they said the third one is 1.5 times larger than the second. Right now we just explained what? We explained why the 9 times.
Yeah.
Now explain to me, why is IE2 and IE3 not so different? IE2 and IE3 means you go from Na2 plus, which is 1s2 to s2 to p5. Or was it 2p6? 2p5 in Bella. And Na3 plus was 1s2 to s2 to p4. Right? So going from here to here, we're losing from what?
2P.
Okay. Going from here to here.
You're losing.
Again from what? 2p.
2P.
Since they're both being removed from 2p, it's not going to make a huge difference, right?
Yeah.
Okay, so this is the first explanation. 2 marks. Perfect. The other 2 marks, you're going to have to say between IE2 and IE3, both electrons are being removed from where?
from 2p.
From 2p. Therefore, it will not make a huge. Therefore, no, they will require similar. It will require similar amounts of energy to remove the electrons. Got it?
I have a question. Okay.
Please ask.
Now, if when you go from the first ionization to second ionization, don't you also lose from 2p?
Yeah. What?
So
What?
does
First to second?
yeah, like from the plus to 2 plus?
From 2 plus to 3 plus or 1
No,
plus?
from plus
Hey,
to
man,
2
that's what
plus.
I just showed you now.
Okay.
Na to Na plus. This is known as IE what? 1.
One.
Na plus to Na2 plus is.
Okay, you start from NA.
Yeah,
Okay.
you get what I mean?
Okay.
I was asking myself the same question in my head. Then I was like, wait, shit, IE1 is this? You get me?
Yeah.
Does that explain your question?
Yeah, it does.
Okay, perfect. Okay. هلا we're gonna do question 11. Which of the following graphs represents the first ionization energy variations from left to right across period 3 in the periodic table? What did I tell you? How does it look?
From if they
Okay,
want from
in general, sorry, I'm sorry for cutting you off. In general, across a period, what happens to IE? It increases or decreases?
across period increase.
Increases, right? So
Yeah.
it should be this, right? But نحن we know we have a few what? We have a few exceptions,
Decrease.
right?
Yeah.
At what groups do we have the exceptions?
2, 3, and 5, 6.
Perfect. So which one's gonna be?
Okay.
Excellent.
I
You
remember
understand
your
it, yeah?
1, 2, 3, 4, 5, 6.
What?
I remember your 1, 2, 3, 4, 5, 6.
Yeah, yeah. It went like this, then this, then this. 1, 2. I drew it for you, المهم. This is exactly how it looked.
Yeah.
But I just labeled it. 1, 2, 3, 4,
1.
5, 6, 7, 8. How do the ionization energies change across a period and down a group? Across a period, we just said that ionization energy what?
Increase.
Down a group, obviously, it's what?
Decrease.
Okay. Across a period, I always told you, who do we remember?
Across period.
Mm-hmm.
Who do you remember the? It's got shielding effect.
لا. Who that?
Uncle Jen.
Uncle Jank. Perfect. Okay. How do you justify that across a period it's decreasing the ionization energy? You don't write Uncle Jank, huh? Say
Yeah,
no.
I won't. Obviously, I won't.
What do you say?
Greater electron nuclear attack.
Greater
No,
effective.
and greater effective nuclear charge.
Perfect. Right. So greater effective nuclear charge. So you say across a period, ionization will
Increase.
ionizing energy. Ionization energy will increase due to the greater effect of nuclear charge, which will attract the valence electrons closer towards the nucleus, and therefore it will require more energy to overcome their attractions. La 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 la. But what's the most important thing to remember? Remember the Uncle Jack. Family comes first, man. Okay? Okay, المهم. طيب, how about down a group? Why does it decrease? Now, what does ionization energy depend on? Do you have any idea?
The shielding effect.
Shielding effect, perfect. That's the first one. Second one?
The nuclear charge.
Excellent. Okay, so down a group, what increases?
Down a group, the nuclear charge. No,
we said across a period, nuclear charge increases. Jank,
yeah.
He's really obsessed with nuclear charged. Okay, down a group, what happens? What increases?
Shielding effect.
Shielding effect. ليه?
Number of core electrons
increases. So, as you go down a group, can you hear me fine, by the way?
Yeah, I can.
Okay, as you go down a group, the number of core electrons increases. Therefore, the shielding effect increases. تمام?
Yeah.
Yeah, therefore the shielding effect increases. Therefore, Sorry, I got lost. What the fuck was I saying? Yeah, as you go down a group, core electron increases, shielding effect increases. Therefore, there will be less what nuclear attraction,
Yeah.
and therefore the valence electrons will be further away from the nucleus. Therefore, it will need less energy to break. تمام?
Yeah. Doesn't need more energy to like penetrate through.
If it's further away, do you think it needs more energy or less energy to overcome the nuclear attractions?
To overcome it. Okay.
Yeah, you get me?
Yeah.
Yeah, perfect. So, ionization energy decreases down a group due to the increase in both the shielding effect and the distance between the nucleus and the valence electrons. Both
Do we
these
mention the what's it called
radius,
nuclear level, nuclear energy level?
nuclear energy level. Why not? Why not? Yeah,
Okay.
because by the way, increase in nuclear energy level means increase in core electrons
Yeah.
for the same group, huh?
Yeah.
تمام. So much talking, شايف? So much talking. How many questions do we have?
That's why I want to do chapter two.
Huh?
That's why I wanted to do chapter two.
Mm, so many questions. Oh, we won't know if we finish this all today. Do you
Yeah,
want?
there's no way.
We can go. These two look nice. We can do these. This wow question. Whoa.
What?
Part A, B, C, I. This looks like a written question.
Let's be honest, yeah. But to be honest, do you think you'll have enough time? That's the question.
Of what?
To able to like solve the written.
Hey, don't worry.
No, like with the multiple choice. If
يا
this
عمي
comes
لا
with,
لا
let's say,
don't worry. One page حلوة. You need to be fast. Okay, always you know what my chem teacher tells us. She says your greatest enemy up in the exam hall isn't Philip. I think
it's
do you
still
remember Mr. Philip from when you were here?
no. I don't remember like the it's called. I left grade seven.
Yeah.
Uh,
Mr. Philip, the Indian exam hall teacher.
oh yeah, that
Yeah,
guy.
you
Yeah,
remember him? Yeah, she
yeah.
always says the greatest enemy up in the exam isn't the questions, isn't the exam, it isn't Philip. It's always the time. Okay? So be as quick as you can.
Didn't you have also Mr. Mustafa?
A lot of shit changed since then, man.
No.
He left a long time ago. المهم خلاص make your order. Finish this question. إذا بدك tomorrow we can continue these.
Mm.
1, 2, 3, 4. لأنه 4 pages يا أخي. We're already more than an hour in.
Okay, yeah, but tomorrow,
Uh,
what time do you want it to be?
Kevin, are you fine with the same time?
Yeah, I think I'll be fine.
Okay, perfect. Okay, periodicity is the recurrence of the same pattern across the
But
rows.
I'll double check though.
Yeah, okay, let me know, don't worry. أنا كمان I will double check. I think I can do maybe earlier, but I'm not sure. It's
No,
recurrent.
earlier I can.
Okay, you can't?
I think I could do from three, 3 till 5.
Yellow, no, 3 to 5, I definitely will be out.
Oh, okay.
Anyways,
That's
yeah, لا والله I'm telling you, it's just this weekend. Usually Friday, Saturday, Sunday, I'm so free. But my dad's coming from Lebanon. He only comes for
yeah,
one
yeah,
weekend every month. So that's why.
yeah.
Periodicity is the recurrence of the same pattern across the rows of periodic table. This graph shows the ionization energies across period 2. As you can see, it's our famous squiggly diggly graph,
Yeah,
yeah? Okay.
yeah.
Determine the term first ionization energy. Give me your definition and I will write down the correct definition together.
Okay, first ionization energy, it's like the energy required to remove one electron
Perfect.
uh, from an atom. Should I say gaseous atom?
Yes, 100%. If you miss gases,
Remove
you're gonna
one,
get it wrong. You're gonna get it all wrong.
yeah, to remove
Okay?
one electron from one gaseous atom.
To remove, you could say one valence. Or no, what the outermost. Okay? نحن in my copybook I wrote the outermost.
Okay.
In the course revision they wrote the most loosely bound, which means outermost يعني.
Outermost
Yeah,
خلاص.
energy required to remove the outermost electron from each atom in
Gaseous atom وليد.
one second, one more of gaseous atoms to form positively charged gaseous atoms. Got it? Because ionization energy,
But they said only the first,
rule,
not the ionization energy itself.
kilojoule per mole. You know that? It will be, I don't know,
Yeah,
500.
yeah,
I don't know how much. But always the unit is kilojoule per.
more.
So you need to say it's energy required to remove the outermost electron from each atom in 1 mole of what atoms? 1 mole of
Uh,
gaseous atoms
First
to
atoms.
form 1 mole of also positively charged gaseous atoms. Is it possible to get negatively charged gaseous atoms?
No.
Yes, it is. I told you this last time. They got it in
Oh
a
yeah,
shitty
the
periodic
X
last
minus.
time. I told you
Yeah.
N3 minus. They said write the first ionization energy. What do? Literally, you just
Uh,
do this.
yeah.
Akid gas, huh?
Oh no, wait, that's wrong.
Why?
Oh yeah, it's Alexa actually.
Okay?
Okay.
You get me?
Yeah. Isma, they said first, not the definition of ionization energy. So shouldn't we say we're not allowed to say each atom?
Yeah, each atom in 1 mole.
Yeah, but they said first ionization, not the definition of ionization itself.
Okay, well, so what should it be? From 1 atom, are you saying?
No, I'm saying like ionization because if you say second, you're gonna say one from the first, صح?
What do you mean?
Let's say they said define the term second ionization.
Okay,
Okay. What would you read?
the energy required to move the outermost electron from each atom in 1 mole of gaseous atoms to form positively charged gaseous atoms. بس
Yeah,
يعني
but why each atom? Aren't they the same atom?
elaborate a bit more.
يعني let's say Li plus and Li, aren't they the same atom? But
They're the same.
why?
No, they're not. This is an ion.
Yeah,
This is
this
an
ion,
atom.
this atom, yeah, but they're like almost like the same substance.
Okay. Okay, what would you say? Tell me what you would say, and I'll correct you.
I don't know if, like it's to remove the outermost electron. Okay, I don't think you're supposed to say each atom, like 1 mole of gas atom from.
No, Mahi, the definition says, you're working, the energy I told you, it's in 1 mole. Okay? You
Yeah.
can't take 2 moles, sorry. You can't just take 1 atom out of the whole mole, وخلاص you leave the rest. لا. The,
Okay.
the definition is every atom in the mole has to lose an electron. Okay?
Okay.
خلاص. First, second, third, fourth, 75th يا خي. Write this down.
Okay. Even if they say second or third, so.
It doesn't make a difference. The whole point is what they're looking for يا خي is to remove أول شي this, okay, outermost electron. They're looking for this 1 mole of gaseous atoms, and they're looking for this to form positively charged. Okay, أكيد
Okay.
gaseous. Okay,
Yeah.
I'm telling you, I'll cut my hand off into 3 pieces if people won't get deducted marks for not saying gaseous. أكيد they're gonna get deducted if they don't say gaseous. تمام؟ I explain why the first ionization energy Li is less than F. طب let's take a look. أول شيء Li is over here, F is over here. So these are pretty far away from each other.
Yeah.
What do you think?
So Li is a cation, F is an anion.
No.
Okay.
Sincerely.
I'm just like.
Why would you say that? Ionization energy will always get you a positive.
Yeah, I know, but I'm talking about like the energy level itself.
Alright. These are across what?
Across period.
What happens across a period?
Junk.
Exactly. Jank. Uncle Jank. Please don't forget Uncle Jank, okay? Type. So what's part B? What would the answer be? The first ionization energy of an element. Sorry, no, that's something else.
Because as
Okay.
you go
Yeah.
across a period.
As you go across a period, or as you go, across a period, there will be a greater effect of nuclear charge. In fluorine, you don't just say that. I told you, remember, when you're comparing 2 things, you have to say this is bigger than this. Okay?
Yeah.
In fluorine, the charge of the nucleus, you could say, is +9, right? Because the atomic number is 9. In lithium, the charge of the nucleus is +3. Therefore, there will be a greater nuclear attraction in fluorine than in lithium, and therefore, you would require more energy to overcome those attractions. So you could say, however, the nuclear charge of F is greater than Li, which means that the F nucleus attracts its valence electron stronger than Li. As a result, there will be greater energy required to remove an electron from F. Capiche?
Yeah.
Got it. Do you have any question?
No.
Yeah, let's go to C. The table, or the graph, sorry, shows the first IE of elements in the periodic table. You can see them.
Yeah. Why did they say successive? That's my question.
Successive.
Yeah.
يعني I think they mean يعني after each other in the period maybe.
Maybe.
But let me think, wait. If it goes up in group 2, ionization as you go down a group, sorry, a greater period, it increases. Bala, yeah, it is as you go across the period. As you can see,
Uh,
it's our famous shape.
yeah.
You know? Hey, cake, hey, cake,
Yeah.
hey, hey. And then all of a sudden it goes down and then same shape. You get me?
Yeah.
Yeah? Okay, no, it's 2 periods actually. You get
Yeah.
what I mean? You know, they finish the period, they reach
And
the
then
noble
went to another.
gas, then they went to another one. You get me?
Yeah.
Yeah. Explain why the ionization decreased from B to C. خلينا نشوف from B to C.
Go to group three.
Okay, explain. Do you know what the
Okay.
answer was for this?
Group three. Look. It's gone. Group three. It will require less energy. I know I'm not saying the full like
Yeah,
the
yeah.
answer, but
Tell me.
group three. It will require since it has like what's it called. Uh, Wait, can you draw the box one? Because I need to remember.
1 second. I'm reading the solution. It's not group 2, group 3. This is Awana. This is group 8. This is group
Oh,
1.
oh,
Uh,
okay. That's a whole different thing.
that makes. So I wouldn't have gotten that to be honest. I'm reading the solution now. How would you recognize this in the exam? When you see a huge jump like this, that means you're going from a new period. You're going to a new period. You get what I mean?
Oh, okay.
Okay, so 8 and 1. تمام?
Yeah.
So it would be a lot better if I drew the periodic table شوي. A, B, C. Get me?
Yeah. Mm. By the way, they made a mistake.
What do you mean?
There's two E's.
Am I blind? I don't see.
Beside the D and above
Ah,
K. And look at part double I.
yeah, yeah. What can we do? B, G, K, L. Ya Allah. Yeah, it's okay, it's okay. Or maybe it's the same element. No, but that makes no sense. How can the same element have two different ionization energies?
Yeah.
Anyways, yeah, explain why the IE decreased drastically from B to C. So, B and C belong to different periods. So therefore, if they don't belong to different periods, that means C has a greater what? What happens as you go to a new period? What increases?
Yeah. Increases
Yeah.
the Uncle Jug.
No, I'm saying from here to here. مثلا if this is n equals to, what's this gonna be?
That's called
Yeah,
the energy level.
the quantum energy level, right?
Quantum. Yeah.
So you'd say from B to C, n increases, therefore um, C's electrons will be much farther from the nucleus.
Because it has an
Therefore,
extension.
exactly, requiring
More.
less. Hey, if it's further,
No, like more. If you're talking about more to penetrate,
no,
L-
to penetrate. What do you mean by penetrate? By the way,
like
you
more
mean the
more
electrons are? Oh, no, I still actually I don't get it. What do you mean by penetrate?
like requires more attraction.
No, don't
More.
say that in the exam. Okay.
Okay, don't talk about
No,
attraction.
حل عني عن attraction. تل attraction يحل عنك شوي. We don't want
Okay.
to listen to him. Okay, for now, here I'm saying requiring less energy to overcome the nuclear attraction. This is what you do with nuclear attraction. ما تقلي penetrating, I don't know what, don't say that, okay?
Okay.
If something's farther, that means you don't need as much energy to kill the attractions. You get me?
Ah, I remember the example.
You get me or no?
Yeah, yeah.
طيب. What can be deduced about B, E, G, K, and L? I think they're talking about this. Where's G?
Check the answer here about E.
Yeah, I'm looking now. B, I think they mean this E. You're talking about this E. Okay?
Okay.
Uh, G, K.
Okay.
طيب, let's take a look at. They don't mean all of them together. Let's take a look at. Let me think. B, E, G, K, L. Which ones have something in common?
They're like the highest.
Which ones?
Like you
Okay, yeah,
see,
you
like
notice that after each one of these they drop, right?
yeah,
Okay, do you think they drop all of them for the same reason?
no,
Okay, which ones do you think have the same reason?
B and E,
And
K and L.
G. Because this is 1, 2, 3, 4, 5, 6, 7, 8. This is what do you think? What group?
This one to
8. This is also 8. You get me?
So that's 3 periods. Huh?
Huh? A, for this is all 3 periods. But my point is, B, E, G are what?
The same.
Noble gases.
Yeah.
You know, noble gases have the highest ionization energy in the whole periodic table. Because
Yeah.
they're
Because,
unreactive, you know? It's
yeah.
like telling, what's that one animal who always sleeps?
It's sloth.
Sloth. Exactly. That's exactly. It's like telling a sloth to go and do laps for you. You know, what the fuck? I mean, it doesn't work like that, right?
Yeah.
Hey. Same thing here. The noble gases, that's why they have the highest ionization energy, because they're so stubborn to lose an electron. They don't want to lose. They think they're the best. You get me?
Yeah.
Okay, so that's why they have the highest ionization energy. But when you look at K and L, they're both also decrease after, صح?
Yeah.
Yeah. Now, in what groups are K and L?
That's 1, 2, 3, 4, 5.
Exactly. So this is 5. This is 5. So you say B, E, and G are group 8
And
elements. K and L are
group 5.
group 5 elements. طب let's
Deduce.
مش deduce. ما بدي deduce. Why would هلا أنا Watfa question هاي.
Okay.
From K to Z, and I don't know, L to W for Walid. Why is there a drop in ionization energy? Maybe there's another question about it later, but why is there a drop here?
This is from group 5 to group 6 exception.
Yeah, what's the reason? We said from group 2 to group 3. Why was it an exception?
Group 2 to group 3, it's called less energy.
لأنه you're removing. I know, but from group 2 to group 3, I need you to memorize these two. I don't know if it's. Is it here? It is.
Remember, to require more energy to remove.
Because they're here. When we do them tomorrow, I'll mention them. But I need you to know the reason.
Is the group 5 and group 6, it requires more energy to remove the.
Yeah, they all require more energy, but why? That's the question. Okay, for these two, 15 and 16.
That's electron repulsion, so.
16 is electron repulsion. But 15, because removing from S is easier than P. You got me?
S easier.
You'll see tomorrow. Okay? I'm gonna put the star beside this. تمام. We're done for today. How do you rate it?